Hello, everybody. My name is Mohammed Ablahay, and I'm going to be talking about glass ceramics, a material that combines the best properties of both glass and ceramics. We'll be explore how they're made from raw materials to finished products. What is glass ceramics? Glass ceramics is made by controlled crystallization of glass, a combination of properties from both glass and ceramics, a fine-grained crystalline structure inside a glassy matrix, a high strength and thermal shock resistance, and it has low or near zero thermal expansion, which is like resists cracking with temperature change, and has an excellent chemical durability and can be translucent or optic. Uh, the molten glass is first formed and then carefully heated, treated so that tiny crystals grow inside it. This combination gives glass ceramics this unique strength, hardness, and resistance to the temperature change. The raw materials and mining. So the key raw materials are silica, sand, alumina, lithium compounds, often from spodumene, feldspar, and other oxides from desired properties. The mining and refining or silica is extracted through open pit mining, which is like washed, crushed, and sorted. Lithium is obtained from hard rock or brine, refined to high purity, and all materials are ground into fine powder for melting. This stage gives us the part glass part of the glass ceramics. The glass ceramics combine the transparency and workability of glass with the strength and durability of ceramics. For example, they can be polished like glass, but are tough like porcelain. This makes them ideal for both decorative and industrial purposes, such as kitchen cookware or high precision optical mirror. The melting and forming the base glass. Uh, like raw materials are batched and mixed in precise proportions, heated in a furnace at 1,400 through 1,600 Celsius to form a homogeneous molten glass. Molten glass is then formed into shapes depending on the product. Sheets or panels, cooktops, example like a cooktop, rods or ingots for machining and pressed into molds like dental blocks. Uh, they have a fine-grained crystalline structure desired within a glassy matrix. The structure is what makes them different from ordinary glass. The crystals are often lithium aluministic, magnesium aluministic, or other oxide compounds. The combination provides both mechanical toughness and low thermal expansion, and the high strength and thermal shock resistance. So the glass ceramics are much stronger than normal glass. They can handle sudden temperature change without cracking. For instance, glass ceramics stovetop panels can go from hot to cold rapidly without breaking. This property is also why they're used in laboratory equipment and cookware like Corning ware and Vision glass pots. The controlled crystallization creaming, nucleation heated to 500 through 600 Celsius to create tiny crystal nuclei inside the glass. Step 2 is like the crystal growth, which is heated to 600 through 900 Celsius for several hours to grow the crystals, and the crystalline phase forms within the glassy matrix. So low or near zero thermal expansion because they're of the crystal structure. Many glass ceramics expand very little when heated. A famous example is Zidor, used in telescope mirrors, with maintains its shape even under extreme temperature change shifts. This is essential for precision instruments like space telescopes or laser systems. The finishing processes like machine and polishing to precise dimension, cutting or water jetting shapes for specific design, and surface treatment for smoothness and durability. Chemical durability is for the glass ceramics resist corrosion and chemical attack from acids and alkyds. This makes them suitable for chemical processing equipment, kitchen surfaces, and biomedical implants. They need to stay stable in harsh environments. For example, micro glass ceramic is used in vacuum systems and semiconductor manufacturing tools because it doesn't react with chemicals. Uh, for product example, cooktop surface, like is used material used lithium alkyd glass ceramic. Why? Because it withstands rapid temperature change, remains flat and strong under repeated heat, and resistant to scratch and stain. Manufacturing focus was the large panels are formed, cremated and polished and cut to size. The edges are finished to reduce stress concentration, and de- decorative patterns or controlled may be printed under the surface. So the appearance, the glass ceramics can be transparent, translucent, or opaque, depending on how they're made. For example, transparent types are used in optical lenses and dental restorations. Opaque types are used in cookware, countertops, and decorative panels. Like I said, colors and light transmission are controlled during the heat treatment process. Uh, so the manufacturing process was melting raw materials like silica, alumina, and lithium oxide are melting together at high temperatures, forming like the molten glass is shaped into the desired form, sheets and rods. Creaming, creaming, the formed glass is reheated to promote nucleation and crystal growth, transforming into glass ceramic. And the finishing is the polishing, cutting, and coating processes are added depending on the final use. For example, like in making glass ceramic cooktops, like I said, our large sheets are melted cast and then heat treated to create a durable, smooth surface that can withstand direct heating. Um, Other finished products are like I said, dental crowning, machinable blocks, and telescope mirrors, which is zero door glass ceramic. Uh, so my conclusion is that the glass ceramics are engineered throughout controlled crystallization of glass. Their unique thermal and mechanical properties that make them useful in many industries. Manufacturing involves mining, melting, forming, cremating, and finishing. The real world application includes cooktop, dental restorations, and optical instruments. Uh, Examples like Pyocreming, the first glass ceramic invented by Corning, used in cookware and stovetops. Zitterer, developed by Scotch, used in telescope like the Hubble Space Telescope. Macro, a machinable glass ceramic used in aerospace and electrical installations. Lithium distillus, common in dental crown for strength and natural appearance. And Surin, a brand of glass ceramic cooktop material that can withstand high heat and temperature change. Uh, Glass ceramics are a remarkable material that bright the gap between glass and ceramic. They offer strength, durability, and heat resistance, which make them valuable in fields ranging from home home cookware to aerospace engineering. Throughout process control of crystallization, manufacturers can tailor glass ceramic to fit almost any industrial or household appli- uh, application. Thank you so much. You have a nice day.